Hello from wherever you are in the world. Welcome to the penultimate episode in our Lawo Lounge series, the show that educates, entertains, and hopefully inspires you to think differently about new workflows in live media production. Today, we are talking about all things mosaic, as our media infrastructure team are here to share with you the uniqueness of our distributed multiviewer solution. Also coming up, we visit the European Parliament to see how Lawo has provided one of the most sophisticated and largest IP AV systems in Europe, a project so prestigious that it subsequently won the Public Sector Project of the Year award at the 2019 AV Awards. But first, it's time to meet another face from the Lawo team. And this week, it is the turn of our head of R&D, Patrick Warrington, as we meet and greet. Hi Patrick, thanks for joining.
Oh, hi Jamie.
Now, you are relatively new to the Lawo team, and I'm keen to find out what you think of the company so far. So tell me, what's your favourite thing about working for Lawo?
Right. Well, the thing that struck me when I first got involved with Lawo is the open culture, and I really like this because communication is encouraged and valued, and it seems that nothing is off the table. And this means that ideas and experience and expertise naturally get shared, and this creates a vibrant ethos in the company and is very motivating, I think, for the staff, and it's certainly very motivating for me personally.
Yeah, now Lawo has over its 50-year history gained a real reputation for innovation. In fact, I believe it's actually in the company's DNA. Now, you're heading up a talented team of R&D engineers, so part of this responsibility sits on your shoulders. So from your perspective, how do we cultivate this innovation culture?
Yeah. This is a really interesting question, and I certainly agree with you that innovation is in the DNA of Lawo. I think that most engineers are naturally creative and innovative, and it's down to an organisation to create the environment in which this innovation can be harnessed and encouraged. And Lawo does this successfully, and it does it by creating a climate that values innovation. And there's a number of ways in which this happens, but I think probably the most important is that Lawo regularly takes a portion of the R&D budget and invests it in projects which aim to explore a technology and don't necessarily have a definite or specific product concept in mind. And what this does is that it creates an environment in which the engineers can think in unconventional ways and think more long-term. And importantly, they don't have to be afraid to fail. And I think this is a really important way in which we can we create a culture of innovation in Lawo.
Now, Patrick, with some of my previous victims on our meet and greet, I've introduced what I call the speed dating question round. This is where I fire 10 quick fire questions at you so we can get to know you a little bit better. Okay, so are you ready?
I am.
Okay, here we go. Is it Beatles or Rolling Stones?
Beatles, all day long.
Chips or fries?
Chips, as long as they have salt and vinegar and gravy on them.
Android or iOS?
Oh, it's got to be iOS for me. I think there's an apple-shaped part of my brain in there somewhere.
Okay, 4 wheels or 2 wheels?
Oh, it's got to be 2 wheels, as long as there's pedals and a chain and no engine.
Rather personal one, this one. Bathtub or shower?
Well, I want to say, it depends if I'm alone or not, but I probably can't say that, can I? I have to edit that out. For me, it's got to be bath, I think, if I have the time.
This one being English, we should know this. Tea or coffee?
Oh, it's coffee in the morning, tea in the afternoon.
Now, this is from my generation, and I assume yours. Sinclair Spectrum or Commodore 64?
The Spectrum. I think I did some of my earliest programming on a Spectrum.
Yeah. Okay, here we go. Some more British things. Cricket or rugby, or neither?
Well, cricket, but specifically Test cricket, because what's not to like about a game that takes 5 days to complete and usually ends in a draw?
Exactly. Okay, nearly there. Hotel or camping?
While there's a single hotel room left in the world, I'd take that over camping any day. I don't get on with canvas.
Okay, and last question here. Guitar player or singer?
Well, you can see my guitars in the background. I would say 70% guitar player, 30% singer. How about that?
Okay. Well, I know that you're a guest member of the Lawo band called the Adlibs. So, maybe some of our audience will get to hear you at one point.
Okay.
So, anyway, thanks, Patrick. Thanks for your time. Take care, and we'll see you soon, okay?
Thanks.
Cheers. Bye.
Bye.
Before we go in focus, I want to give you the answer to last week's 50-year quiz question. The question was, what is the name of Lawo's user interface design software that comes with every Lawo radio console? The answer is, of course, VizTool. So congratulations to those who got the answer right. Some Lawo giveaways may be landing on your doorstep shortly. Now to the main feature of this week's Lawo Lounge. A key element to all media infrastructure installations is monitoring, and the growing scale and demands of multiviewer applications has led Lawo to rethink the typical and traditional approaches. Stefan Turkay is here to explain how Lawo's Distributed Multiviewer provides unmatched scale and flexibility as we push your mosaics to infinity.
Thank you, Jamie. I'm very excited to speak about the Multiviewer today. Before we get into the Lawo solution, we figured we ask somebody who has a lot of real-world experience with these types of devices. And for this, we called Jason Taubman. So with us is Jason Taubman, Senior Vice President Technology at Game Creek Video Services, which is one of the leading truck companies, I would say, in the world. Jason, we're very happy to have you in the Lawo Lounge. Welcome.
Thank you so much for having me. It's a great pleasure.
So we're curious. You've designed trucks, many trucks in your career, and with the break to IP, is there anything specifically that you focus on, key aspects, design goals, when you build a new truck or when you approach a design?
Well, the key thing, and one of the things that pushed us to IP to begin with, is the ability to really expand the capability of our trucks while not expanding the weight or size footprint that the equipment requires. So we have now clients who are requesting 4K HDR productions at scale, and in order to pull that off, we're needing to look to technologies that provide a much higher density in terms of the infrastructure, and that's really the key thing that IP enables. Absent the need to or the desire to really move forward with 4K and UHD type solutions, I'm not sure we'd be looking at IP right at the moment.
Okay, and since we are focused in our series or in our little piece here on the multiviewer specifically, I'd be curious, is there anything specific to multiviewers with the shift to IP that is kind of important to you?
Well, the most important thing to us, and this may seem really basic, but the most important thing to us in terms of a multiviewer is the lowest latency possible. For the longest time, we were doing discrete standalone multiviewers rather than a matrix type multiviewer, and really the reason was the processing time in the matrix type multiviewers was just too long. We really try to keep our multiviewers to sub-frame latency where we can in the live environment. So once the IP multiviewer started to appear that could achieve that, we started to think a little more about what other tricks the multiviewer could do in terms of how many pips in one image or one display, all the little additional things that you could view on a multiviewer, such as audio and tally and all the other things are, of course, important as well. But latency is by far and away the biggest concern we have. We tend to, at Game Creek for the longest time, we've been doing fewer pips in smaller displays, so more like quad splits or 8x, as opposed to splitting up the image more times in a larger display. Although now with higher density displays, UHD displays, we're starting to rethink that a little bit.
Okay, great. And now that you are not only designed these trucks, actually you sent them on the road. Is there any experience? How's the feeling of sending these trucks out every weekend and doing production?
Well, I will say that IP is still a brave new world. We now have, with Lawo, we have 3 trucks on the road and 2 more on the way. Every time we put a new truck out on the road, it's a learning experience. And, we've found in general that the IP trucks are as capable as the SDI trucks. There's a much steeper learning curve, however, for our staff in learning how to keep these things tuned up and running properly. Our goal with respect to the client, however, has been to really make the IP infrastructure as transparent as possible to our clients. So in general, our clients really aren't even aware that there's IP behind the scenes. So that's a primary goal in all of our designs, is to really make sure that we're enabling these complex workflows, but in a way that doesn't present an obstacle for our clients.
Great. So I think the most people in the industry are rather on the edge of designing their first truck, or there's many people out there. From your experience, do you have any advice you would give somebody starting now fresh into this exercise?
Yeah, I would say first, be careful what you wish for. The promise of IP is this sort of unlimited canvas to sort of size up an infrastructure as big as you would like it to be. And I found, generally speaking, that as we've gotten into this, you find yourself almost wishing for the confines of an SDI router again, where the limits were really well known, and you really had to stop when you got to a certain point in terms of the size of your infrastructure. The first thing I would say is plan very carefully just how big you want this thing to become, and really try and live within those limits. It's tempting to go and think that the switch that you have and the IP infrastructure that you have provides you with unlimited resources. And it's true that it sort of does, but with this unlimited resource comes a lot of complexity and a lot of configuration to do. And I would say if you can find a way to contain your vision somewhat, you'll probably be much more successful.
Thank you, Jason. This was very insightful to us. Thanks for spending the time with us.
Oh, you're welcome. Thanks for the time.
These were fantastic insights. So let's talk about the Lawo Multiviewer solution. We address multiviewing in our vMatrix ecosystem. vMatrix is our core infrastructure platform that is built on a software-defined architecture. That means there's one generic processing blade which is capable of hosting different types of software applications. And one of these applications is called VMDMV, which is a processing unit to build multiviewing heads. DMV stands for Distributed Multiviewer. And if you load this application onto one of these C100 blades, what you get is a processing engine that creates you 4 3G heads with each up to 64 pips, or one UHD head with an enormous amount of 128 pips in one 12G output. To feed these pips, you can use the rear side BNCs, but vMatrix is an IP core infrastructure platform. So the majority of signals will enter the device as an IP stream. And on the IP side, we provide dual 40 gig interfaces. So very quickly, the question becomes, if you have these enormous amounts of pips on your multiviewers, how do you feed them with input signals? Well, it's a valid question because the amount of signals mean that the more sources you put into the mosaic processor, the more input bandwidth you consume. And there's one dimension is just the number of signals. The other dimension is the resolution of the signal. So each UHD signal will have much more incremental bandwidth than each, let's say, SD picture that you add. So very quickly you see that this curve is going up if you would have to feed this input processor raw signals to display them, which means that you have an enormous amount of pips, but you have very few different signals you could actually show on these pips. And to illustrate this even more, we in our platform use a 40 gig solution. So you see that while you get 150 SD signals theoretically into such an interface, very quickly the number of individual signals you apply to that processor will decrease. Now, one could say, can I solve this problem with larger bandwidth on the network interfaces? And my answer would be not really. Why? Well, let's compare to a 100 gig solution. The 100 gig solution, the jump from 40 to 100 gig solution, for the most part means you can consume more low resolution signals if you would feed them in raw format or in full resolution. So you get a lot more SD signals, a lot more HD signals, but not necessarily a lot more 3G or UHD signals. So what we think is that just by increasing the bandwidth, the interfacing bandwidth towards the networks, and then just feed full resolution pictures, still you'll end up with a multiviewer that is just capable of showing very few individual signals, but you can show them on many pips. So since just adding more input bandwidth to your IP interface does not solve the problem of showing more content on different pips, we took a step back and thought of a different solution how to solve this problem. So if we look at the multiviewer, actually the essence of the device is taking large pictures to scale them down to then show many on one screen. So we talked about the increase of bandwidth with incremental resolution. The opposite is true as well. The smaller the pip gets, the smaller the actual needed resolution is. And if we were to find a technology in which we could just send a stream or an input on the IP sides which equals the actual shown resolution instead of the original resolution, we'd make much more use out of the available bandwidth. This is why we put a technology we call Liveview at the heart of our multiviewer. And what Liveview is exactly that concept of scaling before you enter the multiviewer processor. So what we take is basically the original picture and we create multiple downscaled versions out of it that correspond to typical pip layouts. So we make a quarter, a 16th, a 64th, and a 256. And then we take this data and package it into the exact same container format that is used to stream 2110 content. So it's just a 2110 stream with smaller resolution pictures. And now if we compare, let's say, a 4x4 layout in a 3 gig world between these. So if I had a classic or a traditional multiviewer that needs to consume the full frame formats or the full resolution formats to then scale them down, I would need to consume 16 times 3 gigabit of network bandwidth to actually show one 4x4 layout. In comparison, in the Liveview technology, I don't take the full resolution pictures. At the input of my head processor, I'll just subscribe to streams which have a 16th of the resolution and a 16th of the bandwidth, which means that 16 times a 16th of the bandwidth equals in the same bandwidth that one 3G signal needs. So for the DMV, the input to the multiview at a 4x4 pip layout entirely with different pictures is just 3 gigabit per second. And this is not just a magic number of 16 pip. This is actually the concept of the technology. The more input sources you feed to a head processor in a full resolution, exponentially the required input bandwidth goes up. In contrast, the Liveview technology, the input bandwidth is more or less flat. That's the orange line. The more pips you apply, the smaller resolution pictures we require because we just show small tiles on the mosaic. And the total bandwidth that you consume is flat. So in one head requires more or less 3 gigabit of data rate independent of the amount of pips you show. And we can produce 4 of these heads in a DMV, which means the total amount of bandwidth we consume is 3 times that flatline or baseline bandwidth. So there's a lot of bandwidth of that 40 gig interface, which is just left for other jobs. So since now we have, first of all, used just a fraction of the available input bandwidth of the device to create and populate the pips, we also have another job in the DMV that needs to be solved. We need to create these live views. And that's actually what the same blade that hosts these 4 processors at 3G or the 12G processor, that's what it does in parallel. So it's capable of taking up to 24 inputs, full resolution inputs, from either IP 2110, 2022-6 or SDI, and will create these live view streams, lower resolution copies out of it, and stream them back into the network. And it is important to understand that our multiviewer is not just one single card, and that's the multiviewer. It's actually the entirety of all the cards that spin the DMV. That means each card provides 4 heads with these large-scale mosaic, and each card provides the ability to take a signal and to turn it into these live view streams, and then make it accessible for all other blades over the IP network. We call this a cluster, and our multiviewer works in a cluster which is linked to the network. Logically, it's one multiviewer, and if you have one input, full resolution input, wired or subscribed to one of the blades, immediately it will create these live view streams for all the blades in the network. So you do not need to need the same signal to be put to multiple of these blades at full resolution. You would just connect it to one blade in the full resolution, and you'll be done. You'll have it accessible to all the heads. With this type of architecture, we're now capable of sharing the sources onto any head independent of the physical location of the device. We have so wherever you connect a DMV blade, it is part of that cluster, of that logical group of signals, where each blade can subscribe to the entirety of available lower resolution streams, the live view streams. So in our example here, we have a spine leaf architecture. One part of the system with hosting multiviewer blades is connected to the left side of your network. One part is connected to the right side of your network. So inputs connected to the left side are either IP or SDI inputs, are turned into live view streams in these devices and then streamed back to the network. They can be consumed by any head processor on the left side of the network. If they are requested by a head processor on the right side of the network, they will just subscribe to the live view streams nearest to the resolution they actually want to show, which means that the trunk lines, which are the critical paths and are carefully managed when it comes to bandwidth, are much less utilized as if we were or had to transport full resolution pictures over the entire network infrastructure. To sum this up, Lawo's distributed multiviewer is very efficient on creating high pip count mosaics. Through its live view technology, it's also very bandwidth efficient, specifically if you have higher resolution signals such as 3G and UHD. And finally, puts less load on the network infrastructure if you distribute the different blades all across your network. And with this, I hand back to you, Jamie.
Hello, my name is Wim van Rooij and I'm an educational architect and solution engineer at Lawo. Did you know you can control the DMV heads and create multi-viewer layout in just a few minutes? In this video, I will show you how you can easily control your DMV setup through the wall. So on one side, I have my DMV output. On the other side, I have the wall software that I'm controlling through a normal browser. So what I could do is I can select any of my pre-selected layouts, drag that onto my system, and my DMV output is updated instantly. Let's say we select one of the other layouts, and again, everything is updated directly. If we wish to add some attributes, for example, I would like to add some audio bars, I can select them and it's dynamically updated. Next to that, I can also go and say, okay, I would like to change the amount of bars that we have. So I select my window, go into the bar count, and then depending on what or the amount of VU meters I would like to have, it's been updated. So it's very easy to update your layout. Let's say we go back to another layout, select this one, instantly it's being adjusted. And now what I could do is go into my attributes, go back to, for example, the borders, and instead of selecting monitors, do windows, and do a different border for each individual of my items. And again, we could select a different color for each of them. So you see, it's pretty easy to change your layout with the wall. And now you know how you could control the DMV heads and create the multiviewer layout in just a few minutes with the wall.
VM streaming plus MADI. Plus MADI is a new license option for VM streaming, the gateway application that runs in the vMatrix ecosystem. With this new license, you are capable of taking any rear plate BNC I/O and switch it between operating as SDI and a MADI. With this new feature, you are capable of using vMatrix as a high-density audio gateway. This gateway will allow you to interface with the baseband legacy infrastructure. If you couple the feature with other features of VM streaming, such as the internal sample rate converter, you are also able to bridge different clock domains between your IP system and your baseband system. To learn more, visit our website lawo.com or contact your local Lawo seller.
It is not only in broadcast applications that Lawo's infrastructure solutions are ideally suited. Corporate and public facilities often require AV solutions of similar size, flexibility and quality to solve their complex workflow and system requirements. This was exactly the case for the European Parliament, who realized that IP could solve many of their biggest challenges in signal distribution and content creation. Take a look as we go on the road to Brussels to see how Lawo technology has been used as the core infrastructure in this prestigious installation.
Transparency is the cornerstone of democracy. This certainly holds true for the EU Parliament. The plenary sessions in Strasbourg and Brussels are not only public, but also recorded and streamed live on the internet in 24 different languages. This adds up to an astonishing 45 hours of footage per week of plenary sessions. To make this technically possible, the European Parliament's AV unit, together with Lawo experts, designed and implemented a groundbreaking IP infrastructure.
Within the Parliament, they had a need to receive audio and video from a room and send it from point A to point B. They needed to have the possibility to receive audio and video embedded in SDI. So for that reason, we put all the audio and video channels into a full redundant IP network, and we combine it onto an SDI output with embedded audio. So we can actually grab 32 channels of audio, and by doing that, we actually use the complete network as a big audio and video router.
It's mission transparency. Any spoken word in any language is available to anyone, anywhere, informing citizens, providing simultaneous translations to the members of Parliament, and serving broadcasters and the press. All this is achieved by one giant IP network.
It starts in the room with a Sapphire who is handling all the audio for the room itself, controlled with a VisTool panel. The vRemote 4 unit is converting that into a full IP stream, and it's fully routed to any particular place in the network. On the other side, we have the vMatrix receiving the audio and the video streams from all of the rooms. We are using it to convert back into SDI. And by doing that, we can actually grab the video and the audio from any meeting room, combine it on multiviewers, show it in a technical data center, in a technical room, and distribute it towards both internal and external parties
Mission transparency has resulted in one of the largest AV over IP infrastructures ever realized. Customized touchscreen interfaces allow to patch and monitor the EU's unprecedented multi-language system. Although it's very complex, it's very easy to use.
We created a custom-built solution for the European Parliament, since the operators in the Parliament do not even need to know where the signal is coming from. They press on a touchscreen, they will see on that panel the audio meters and the video thumbnails. They will see that the video signal is present, and from then they can route it to any output. These are the permanent transmission links on satellite from the European Parliament. Like you can see on the Multiviewer, I receive the feed from Strasbourg, so I can cut straight live on that screen and cut any other camera or any other feed. So I could actually go and listen to the original language in that room. But I can also, for instance, listen to the English translator cabin.
I'm not sure about that. 85, we'll check that.
Building such a big infrastructure would have been really hard without that new technology. So we actually guide them using IP technology into a certain flexibility, which in the end is used by you and me.
The European Parliament's audiovisual unit is proud of what has been achieved. And European citizens can be proud too.
It's quiz time once again, as we offer you the chance to win some more of our fabulous Lawo giveaways. This week, we have made our 50-year quiz just a little bit harder, as we have 2 questions for you to answer correctly, both on the topic of Lawo's award-winning Distributed Multiviewer. So question 1. What is the maximum number of pips possible to be displayed on a single head of the DMV? Is it A, 18, B, 36, or C, 128? And question 2. What is the name of Lawo's real-time multi-viewer setup tool included with every DMV system? Is it A, Mosaic, B, the Wall, or C, the View? Now remember, you need both correct to win. So good luck. So unfortunately, that's all for this week's Lawo Lounge. Join me again next week for the last episode in this series, where we invite Tony Zara again to bring our smart solution back in focus. Also, don't forget that you can watch any of our previous week's Lawo Lounge episodes or our Thursday how-to series by visiting our website at www.lawo.com and navigating to the Lawo Lounge page. So thanks for joining us, and until next week, take care, stay healthy, and stay connected. Goodbye.